This is the second half of our single replacement notes. Where instead of cation replacement, we're going to be dealing with anion replacement. So the difference being, last time we had A representing a cation, which it still does, B representing an anion, which it still does. But now instead of another cation here, we're going to have another negatively charged ion. Specifically, we are going to be talking about halogens. So halogens are, if you recall, group 7 or 17, which is fluorine, chlorine, bromine, iodine, and astatine. So as we're looking at that, we're going to be only trying to replace one of those with another one of those. That's the only type of replacement I'm going to be doing for anion replacement. So one of these halogens will be in the formula, your compound for B. So you'll either have fluorine, chlorine, bromine, iodine, or astatine. And then D will also be one of those, but it will be because it's alone in the diatomic form, which is Hoerfinkel. So as we're looking at this, we're going to be deciding, is the halogen in the formula the more reactive one? Just like what we did with cation replacement, the same logic applies here. So using our trend for kind of reactivity, we would expect fluorine to be the most reactive, and then chlorine, and then bromine, and then iodine, and then AT. And this just goes down the column. So the top of the column of the halogens is most, and the bottom is the least. So looking at our first example here, we have our cation of nickel, so currently having a +3 charge. We have bromine as the halogen. Halogens all have a -1 charge, so that will always be true of these types of replacement. So we're going to see, is bromine more reactive than fluorine? And if we look here, fluorine is the more reactive one, so that one should end up in the compound. So nickel now will pair with fluorine. Keeping in mind what we've been keeping in mind, we need to make sure that fluorine does not keep the 2 it had before, and instead gets the 3 from nickel by making the correct ionic formula, as it says here, from the swap and drop. So this becomes NiF3. And then bromine, which has now been displaced, ends up alone. But unlike in cation replacement, where that's all we would do, when it is alone, we need to add that 2 because it is one of our 7 diatomics. And so we must always Hoerfinkel, which is just the 7 things listed out here. Anytime they're alone, you must put a tiny 2. And then lastly, we would have to balance. So we would look at the fact that we have 3 fluorines, 2 fluorines, so we need a common factor of 6 there. And so that means a 2 in front, and then a 3 here. That means 2 nickels here, and then therefore a 3 here as well. Okay, one more example. Oops, sorry. That we can see where this would not necessarily happen is, let's say that we had, we'll do cobalt. Let's say we have cobalt with chlorine. And it is reacting with bromine. Now, according to our reactivity series here, chlorine is going to be more reactive than bromine. So in this case, we would say no reaction occurs because these 2 things would not switch simply because chlorine is already the more reactive thing. So it is the one in the compound.